Hi there Year 7, hope you've all had a really nice Christmas and a really good break. Let's start off with a quick starter for today's lesson. On the board are 5 numeracy questions and an extension question to have a go at. In your rough books or on a rough piece of paper or a mini whiteboard, please pause the video for a couple of minutes and have a go at these questions now. Okay, hopefully you paused the video there and had a go at these questions. Let's go through the answers. 563 plus 88. Well, if I'd done a column addition, I'd have got 651. A column subtraction would have given me 586.6 for question 2. For question number 3, I'd have done 756 multiplied by 3 and then divided my answer by 100, and that would give me 22.68. Adding fractions, I need to convert those fractions into equivalent fractions which have the same denominator. So I'd take 5/8 and I'd multiply top and bottom by 5. Multiplying top and bottom by 5 would give me 25 over 40. I would now take my 1/5 and I'd multiply top and bottom by 8. Multiplying 1 by 8 would give me 8, and 5 times 8 gives me 40, so they've now got the same denominator. Now that they've got the same denominator, I can do 25 over 40 plus 8 over 40, and that would give me 33 over 40. Now for the next one, we need to use our bips, so I do my bracket first. In my bracket, I've got 2 plus 2, and that gives me 4. 4 squared will give me 16. I then need to do my multiplication. Well, 16 times 2 is 32, and 32 plus 4 gives me 36. If you had a go at my extension question, one jumper is worth £13. Well done if you got that right. Okay, we're going to run through the diagnostic quiz now, so that's A, B, C or D. Please keep a note of your answers and then we'll go through the actual answers at the end. So question number 1 for me. Here are 2 regular shapes. They both have the same perimeter. What is the length of one side of the octagon, the orange shape? Pause the video if you need and have a little think about that one. A, B, C or D. Question number 2 for me, Year 7. What is the perimeter of this shape? If I tell you these little lines here mean that every one of these sides is the same length, what's the perimeter of this shape? Again, pause the video if you need and do a little calculation. A, B, C or D. Okie dokie. Question number 3. What is the perimeter of this shape? Remember, you need to work out what this missing length here is. You haven't been given all the lengths. You need to work out the missing length and then add them together to find the perimeter of this shape. Again, pause the video if you need. Question number 4. What's the difference between the perimeters of these 2 shapes? Again, these little lines here mean that those 2 lengths are the same length. So those 2 sides of that triangle are the same length. So what is the difference between the perimeters of these 2 shapes? And question number 5 for me. What is the perimeter of this shape? Again, the little lines here, 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 here and here just mean that every one of those sides is the same length. What's the perimeter of this shape, please? Okay, Year 7, let's go through the answers. Question number 1, the length of one side of that octagon was 3 centimetres because the perimeter of the hexagon is 4 plus 4 plus 4 plus 4 plus 4 plus 4. So the perimeter of that one is 24. We know the perimeter of the octagon is also 24, but the octagon has got 8 sides, so dividing by 8, each of those sides is worth 3 centimetres. Question number 2, the perimeter of this shape, we need to add together 1.5 6 times, which will give me 9 centimetres. Question number 3, you needed to work out what this length here was. This length here is 10 take away 7, which will give you 3. and then if you add those up, you get 46 centimetres. Note it's not centimetres squared because centimetres squared would be an area, and we're asked for the perimeter. Question number 4 for me, the difference between the perimeters of these two shapes was 3 centimetres. And question number 5, again 2.5 plus 2.5 plus 2.5 plus 2.5 plus 2.5 gives me 12.5. The correct answer was A. So for today's lesson, we're going to do a consolidation lesson on collecting like terms. This was a topic we covered in about October, November time, but just to check we can still remember it and identify any misconceptions you might now have. So a quick recap. Here was our algebra tile and we had a yellow square, and I asked you what's the area of this yellow square. Now I'm going to ask Charlie. Charlie, what's the area of this yellow square? Thanks, Charlie. The area of the yellow square is positive 1. So underneath that, I've got a red square. I'm going to ask Evan, what's the area of the red square? Correct, the red square is negative 1. Thank you, Evan. So what happens when I put them together, honey? You're right, honey. It makes a 0 pair, and they make 0. Let's do another. I had a green rectangle. What was the area of my green rectangle, please, Genevieve? Correct, my green rectangle is worth X. So what's my red rectangle, please, Albie? Correct, my red rectangle is negative X. So what happens when I take a red rectangle and I put it together with a green rectangle, Oliver? Great, they cancel out, it's a 0 pair, we get nothing. How about the blue square, Will? What's the area of the blue square? You're absolutely right, Will. The area of the big blue square was x squared because we had a length of x multiplied by another length of x. So what's the area of a red square for me, please? Let's ask Nathan. Negative x squared, you're correct. Lovely stuff. And Jake, can you tell me what happens when I put a red square and a blue square together? You're absolutely right, it makes a 0 pair and I'm left with nothing. Let's put all those different algebra tiles together. I'm going to model this expression on the left side of the board. I've got x squared plus 2 plus 2x squared plus 3x plus 3. Evie, which tile do I need to model x squared? A blue one, brilliant, thanks Evie. Blake, what do I need for positive 2? Fantastic, 2 yellow squares, very wise. For positive 2x squared, I need 2 big blue squares. Positive 3x then, Finlay, what do I need for positive 3x? You're absolutely right. I need 3 green rectangles. And finally, Agnes, what do I need for plus 3? 3 yellow squares. Brilliant. Thank you very much. Now I'm going to collect like terms, by which I mean I'm going to put any tiles that look the same together. So I'm going to put my blue tiles together, my green rectangles that are already together, and my yellow tiles. So if I simplify this expression, I've now got 3 lots of x squared plus 3 green rectangles, which is 3x, plus 5. Each of those yellow squares is worth positive 1, and I've got 5 of them. Over to you guys, pause the video for a minute or two, and in your rough books or on your mini whiteboards, can you please have a go at modelling this one and simplifying it for me? Pause the video now. Rightio, let's go through the answer. So again, 2x squared, I'm going to need 2 blue squares. 5x, I'm going to need 5 green rectangles. 1, 2, 3, 4 and 5. Positive x squared means I need another blue square. Plus 2 means I need 2 yellow squares, here they come. And plus 3x means I need 3 green rectangles. Collect like terms again just means bringing together any tiles that look the same. So my blue squares come together. My green rectangles come together. There they are. And I've got 2 yellow squares. So altogether I've got 3 lots of x squared. I've got 8x, 8 green rectangles, and I've got 2 yellow squares, so positive 2. Okay, Year 7, please pause the video for 5 to 10 minutes and have a go at these for me, modelling them in the same way and then using that to collect like terms and simplify each of these expressions. Pause the video now. Okay, hopefully you spent 5 or 10 minutes working your way through those. The correct answers are now up on the board. Please pause the video and check your work for me. Well done if you got those right. Let's look at a more complicated example. We're going to add in negatives. So I'm going to start off. I've got x squared plus 5 plus 2x squared plus 3x. Take away 3, take away 2x. Now how can I write subtract 3 as addition of the additive inverse? So I want to write subtract 3 as the addition of the additive inverse. Olivia, what does that mean? You're absolutely spot on, Olivia. That just means that instead of subtract 3, I can write that as addition of negative 3. And it means the same thing. Let's use that to model the expression. I've got x squared, that requires 1 blue square. I've got positive 5. Oren, what do I need to show positive 5? You're absolutely right, Oren. I need 5 yellow squares. Thank you very much. 3, 4, and 5. Anita, what do I need to show positive 2x squared? 2 blue squares, lovely. What do I need for positive 3x then, please, Rubs? 3 green rectangles, thank you. Alfie George, if I want to add on negative 3, which means the same as subtract 3, what do I need to add? This is a tricky one. You're right, I need 3 red squares this time. So Max, what do I need to show subtract 2x, which means the same as adding on negative 2x? You're absolutely right, Max. I need 2 red rectangles. There they are. Now I'm going to collect like terms again, so any algebra tiles that look the same are going to come together. Here are my blue squares. My rectangles are going to come together. And my little squares are going to come together. Okay, Ella, what can I do now? You're absolutely right, Ella. I can cancel out 0 pairs. Let's get rid of them. There's 1. There's 2. There's another 0 pair. I can also make 0 pairs out of my rectangles. So I can cancel out that green rectangle with that red rectangle, that green rectangle with that red rectangle. And let's see what I've got left. I've got 1, 2, 3, lots of x squared. I've got 1x, because I've got 1 remaining green rectangle. And Kaylee, how many yellow squares have I got? Spot on, I've got 2 yellow squares. So I can simplify that to 3x squared plus x plus 2. In your rough books or on your mini whiteboards, by modelling this expression, can you simplify it for me, please? Pause the video for a minute and have a go at that now. Okay, let's go through the answers. So positive 3 means I need 3 yellow squares. There they are. Positive 2x squared means I need 2 blue squares. Positive 5x means I need 5 green rectangles. Now I've got negative x squared, or adding on negative x squared, which means I need a big red square. I've got positive 2 yellow squares, and I'm adding on negative 3x, so I need 3 red rectangles. Let's collect like terms. Bringing together my big red squares, bringing together my rectangles, and bringing together my little yellow squares. Let's cancel out some 0 pairs. Here's one 0 pair. Here's another one. Here's another. And here's another. So Josh, what am I left with? Great, I've got 1x squared plus 2x plus positive 5, and I've simplified it. Over to you, Year 7. In your light blue books or on your mini whiteboards, please have a go at these questions. Pause the video for 5 to 10 minutes. Off you go. Okay, these are the answers. Please check your work and see how you did. Okay, Year 7, the hardest type of example we're going to go through now. I'll go through one, then there's one for you to do. I've got x squared plus 3, take away 2x squared, plus 3x, take away 7. Now again, I know that subtracting 2x squared is the same as adding on negative 2x squared, and subtracting 7 is exactly the same as adding on negative 7. And I'm going to use that now. X squared is 1 blue square. Positive 3 is 3 little yellow squares. There they are. Negative 2x squared just means 2 big red squares. There they are. Positive 3x is 3 green rectangles. And what do I need to show negative 7 then, please, Adam? Great, I need 7 little red squares. 1, 2, 3, 4, 5, 6, and one more, 7. There they are. Let's collect like terms. Bringing together my big squares, my rectangles, there's only 3 of them, and my little squares. Here they are. Cancelling out 0 pairs, just like we did before. This guy cancels with this guy. And I can cancel out 3 lots of the little squares. So this time, how many x squareds am I left with, Harry? You're right, I'm left with a negative x squared because I've just got 1 red one. Leah, how many x's have I got? 1, 2, 3, brilliant, plus 3x. And Finley, how many negative 1s have I got? I've got 4 of them. So simplifying that, I've got negative x squared plus 3x, subtract 4. Over to you guys, Year 7. Here's one for you. Pause the video for a couple of minutes, model it using the algebra tiles, and work it out for me. Right, let's go through the answer. This time, I start with negative 3. I add on my 2x squared. I add on my 3x. I then need to add on negative 3x squared. So 3 big red ones. I'm then adding on positive 5. So that's 5 yellow squares. And then I've got negative 5x, so I need 5 red rectangles. There they are. Okay, collecting like terms, I can bring together my big squares. There they are. I can bring together my rectangles. There they are. And I can bring together my little squares. Let's cancel out some zero pairs. This guy cancels with this one. This guy cancels with this one. I can cancel out 3 of these. And I can cancel out all 3 of those and 3 of the little yellow squares. So simplifying it, I've now got negative x squared, because I've got 1 big red square, negative 2x, because I've got 2 red rectangles, but positive 2, because I've got 2 yellow squares. Over to Year 7. In your light blue books, please pause the video for 5 to 10 minutes and have a go at these questions. Cool, here are the answers. Please check your work and see how you did. And that's the end of today's lesson. Please head over to Google Classroom and can you submit today's exit ticket for me? 3 questions, A, B, C or D. That allows me to see who's engaged in the lesson and identify any misconceptions you might have. Have a wonderful day. Thank you very much for listening, Year 7. Off you go. Goodbye.